Imagine flying from London to Sydney in less time than it takes to watch your favorite movie trilogy. The world suddenly feels smaller, distances shrink, and the impossible becomes possible. This is the promise of a new era in aviation and space travel. One where the boundaries of our planet are no longer limits, but gateways to something greater. Picture an aircraft that takes off from a regular runway, just like any commercial jet, but then soars to the very edge of space, skimming the atmosphere before gliding back down to Earth. No need for massive launch towers or complicated infrastructure, just a runway, a crew, and a dream. This isn't science fiction, it's Invictus, a revolutionary project backed by the European Space Agency. Invictus is the culmination of decades of research, innovation, and ambition, bringing together the brightest minds in aerospace to make the extraordinary a reality. Invictus is more than a plane. It's a symbol of our drive to push boundaries and explore the unknown. It represents the spirit of discovery that has fueled humanity's greatest achievements, from the first flight to the first steps on the moon. For centuries, we've gazed up at the stars and wondered what lies beyond. Our ancestors mapped the heavens, dreamed of other worlds, and imagined journeys across the cosmos. In the 20th century, we sent astronauts to the moon with single-use rockets, amazing, but wasteful. Each mission required enormous resources, and the hardware was lost after every flight. The dream of routine, affordable space travel seemed out of reach. Invictus aims to change everything. A reusable spaceplane designed to make space travel as routine and affordable as flying across continents today. Imagine boarding a spacecraft as easily as you would a plane, knowing it will return safely to fly again and again. This isn't just about cost, it's about transforming our relationship with space. With Invictus, space becomes a destination for everyone, not just a select few. It opens the door to new opportunities, new industries, and new ways of seeing our world. Imagine deploying satellites with ease, servicing space stations without the need for disposable rockets, or even flying passengers across the globe in a fraction of today's time. The possibilities are as limitless as our imagination. Invictus is a single-stage-to-orbit spaceplane, a hypersonic dart powered by an engine that breathes air like a jet before switching to rocket mode for the final push to space. This breakthrough technology means fewer parts, less weight, and more efficiency. This hybrid design lets Invictus use atmospheric oxygen for much of its journey, making it far more efficient than traditional rockets. By combining the best of aviation and rocketry, Invictus sets a new standard for sustainable spaceflight. The dream of aerospace engineers is finally within reach. Years of hard work, innovation, and collaboration are coming together to make this vision a reality. The next generation of explorers, scientists, and travelers will benefit from these breakthroughs. Invictus could make space accessible, routine, and sustainable. It's not just about reaching orbit, it's about building a future where space is part of our everyday lives. It's the next vessel for humanity's grand adventure. With Invictus, we stand on the threshold of a new chapter in exploration, ready to write the next story among the stars. The future of flight is about to change forever. The sky is no longer the limit, it's just the beginning. Invictus's goal is nothing short of revolutionary, creating a reusable vehicle that can not only achieve hypersonic flight within Earth's atmosphere, but then seamlessly transition to rocket-powered ascent into space. This vision pushes the boundaries of what's possible in aerospace engineering, blending the speed of advanced jets with the power of rockets. Hypersonic means traveling faster than Mach 5, over 6,000 kilometers per hour. At these speeds, you could cross continents in under an hour, and reach the edge of space in minutes. Invictus aims for an astonishing Mach 25 to reach orbit, 25 times the speed of sound. That's the velocity needed to break free from Earth's grip and enter space. But at these extreme speeds, the air itself becomes a barrier, a wall of searing heat, hot enough to melt most metals and destroy conventional aircraft. The space shuttle survived the fiery return to Earth using thousands of ceramic tiles. Invictus, however, must withstand this intense heat not just during re-entry but also while climbing up with its engines blazing at full power. The real engineering challenge is immense, designing an engine that can operate efficiently from a standstill on the runway all the way to the vacuum of space. Traditional jet engines simply can't handle hypersonic speeds. They fail when the air rushes in too fast to compress and ignite fuel. On the other hand, rockets are powerful but burn fuel inefficiently in the thick lower atmosphere, wasting precious energy. That's why Invictus's hybrid engine is so groundbreaking. It must adapt to both extremes, breathing air at lower speeds and switching to rocket mode as it climbs higher. The ultimate goal is to make access to space as routine as air travel, dramatically slashing costs for launching satellites, conducting research, and even tackling the growing problem of space debris cleanup, ensuring safer orbits for future missions. Europe is determined to secure independent, sustainable access to space, moving away from disposable rockets and toward reusable, eco-friendly solutions. Invictus represents a strategic leap forward, driving innovation and sustainability in the new global space race, and inspiring a new generation of engineers and scientists. The future of flight and our ability to explore beyond Earth depends on solving these extraordinary challenges, unlocking a new era of possibility. At the very heart of Invictus lies a revolutionary piece of technology, the SABRE engine, short for Synergetic Air-Breathing Rocket Engine. This isn't just another propulsion system, it's a bold leap forward in aerospace engineering, designed to bridge the gap between jet engines and rockets. SABRE is a true hybrid, functioning as a jet engine while within the atmosphere, and transforming into a rocket engine once in space. This dual capability allows it to operate efficiently across vastly different environments, something no traditional engine can do. Up to an altitude of 25 kilometers, SABRE breathes in atmospheric air, using it as oxidizer. When the air thins out, it seamlessly switches to burning internal liquid oxygen, providing the thrust needed for the final push to orbit. This transition is both smooth and automatic, ensuring optimal performance at every stage. During ascent, the engine scoops up air at incredible speeds, compresses it, mixes it with liquid hydrogen, and ignites the mixture, enabling the craft to reach speeds of Mach 5 while still within the atmosphere. This is faster than any commercial jet, and it happens before even leaving Earth's airspace. Once at high altitude, SABRE transitions to rocket mode, burning onboard oxygen to accelerate the vehicle to an astonishing Mach 25, fast enough to break free from Earth's gravity and enter orbit. Achieving this seamless switch between air-breathing and rocket modes is a major engineering feat, requiring cutting-edge materials and precision control systems. Thanks to SABRE's efficiency, Invictus can carry far less liquid oxygen than a conventional rocket. This makes the vehicle significantly lighter, more cost-effective, and fully reusable, key advantages for future space missions. Traditional rockets are essentially giant fuel tanks, burdened by the need to carry all their oxidizer from the ground. SABRE's air-breathing mode changes the game, allowing the craft to use the atmosphere as a resource. Imagine a hiker who refills their water bottle at streams along the trail, instead of carrying all their water from the start. That's the advantage SABRE brings to space travel. The result is a smaller, lighter, and more practical spaceplane, one that can be launched, landed, and reused with unprecedented ease. SABRE's groundbreaking innovation sets Invictus apart from every spacecraft that has come before, opening the door to a new era of space exploration. With this engine, we stand on the brink of redefining how humanity reaches space, making access to orbit faster, cheaper, and more sustainable than ever before. The SABRE engine's secret weapon is the pre-cooler, a marvel of engineering. At hypersonic speeds, incoming air heats to over 1,000 degrees Celsius, enough to destroy any engine. The pre-cooler cools this air to minus 150 degrees Celsius in a fraction of a second, making it safe for the engine. It's a web of ultra-fine tubes chilled by helium that instantly absorbs heat from the incoming air. This rapid cooling makes the air denser, boosting engine efficiency and thrust. Engineers had to make it lightweight, robust, and frost-resistant, a huge challenge. Ground tests proved the pre-cooler works, simulating Mach 5 conditions. This technology is the key to SABRE's success and Invictus's future. Without the pre-cooler, air-breathing hypersonic flight would remain a dream. It's a testament to human ingenuity under extreme conditions. Invictus is a grand collaboration, uniting Europe's brightest aerospace minds. The European Space Agency leads, providing vision and oversight. Reaction engines based in the UK developed the SABRE engine and pre-cooler. Industry giants like Ariane Group and Thales Alenia Space contribute expertise in materials, avionics, and integration. Universities and research centers across Europe tackle everything from aerodynamics to advanced materials. Invictus is a pan-European effort, proof that bold visions require united teams. Invictus's journey is a marathon of innovation, broken into careful phases. Early stages focused on proving SABRE's core technologies, especially the pre-cooler. Next, integrate SABRE into a demonstrator aircraft for real-world flight tests. The team will use smaller test planes before building the full-scale Invictus. Flight tests will begin within a few years, focusing first on air-breathing hypersonic speeds. Each test refines the design, leading to a full mission runway takeoff, hypersonic ascent, rocket transition, orbit, and gliding return. The first full-scale uncrewed Invictus could fly in the 2030s. Success would prove single-stage to orbit is possible, opening a new era in space travel. Invictus could reshape our world far beyond aerospace. Reusable space planes could slash satellite launch costs, opening space to more nations, universities, and startups. A new wave of innovation in communications, research, and Earth observation would follow. The same technology could enable hypersonic passenger flights, Paris to Tokyo in 3 hours. Our world would feel smaller, more connected, and more dynamic. The project's breakthroughs in materials, cooling, and control systems would benefit many industries. Lightweight, heat-resistant materials and efficient heat exchangers could transform everything from cars to power plants. But new technology brings new challenges. Airspace rules, security, and fair access must be addressed. The promise is huge, but so is the responsibility to integrate it wisely. Invictus's impact will reach far beyond the launch pad. It's a catalyst for global change. What about the environment? Traditional rockets pollute, but Invictus aims for a cleaner future. SABRE burns hydrogen and oxygen, producing only water vapor, no carbon emissions. Its air-breathing mode is vastly more efficient, using less fuel and reducing the environmental footprint. Reusability means less waste, no more discarded rocket stages. Still, questions remain about water vapor in the upper atmosphere and its effects. Scientists are studying these impacts to ensure sustainability. Invictus's goal: reach space as responsible stewards of our planet. The future of flight must be green as well as bold. Invictus is more than a machine. It's a statement about our future. It marks a shift from disposable rockets to sustainable routine space access. The SABRE engine's decades-long development shows the power of patient, ambitious research. Invictus is the result of collaboration across governments, industry, and academia. The journey will be tough, but the technology is sound, and the vision is clear. Whether Invictus looks like today's concept or evolves, its legacy is already taking shape. It pushes the boundaries of science and engineering for everyone's benefit. Above all, Invictus embodies our urge to explore, the next ship for humanity's greatest adventure. It could shrink our world and open the universe. Invictus is truly a leap for humankind.